In this video, we're going to look at ways that you can change the reporting options for data within CHEMCAD and export data out of CHEMCAD into other applications. We're also going to take a look at CHEMCAD's capability to size lines. By the end of this video, if you follow along, you should be able to define and edit customized property sets. You should be able to define and edit stream sets. You should be able to change CHEMCAD's reporting options so that you can send reports to other applications. And you should be able to use CHEMCAD's built-in capability to size process lines. The framework for this example is going to be the system that shows up at the end of the third heat transfer video, where we're cooling benzene and heating xylene. We need to size 8 lines in this process. The 2 lines that carry benzene, streams 1 and 2, the 2 lines that carry xylene, streams 3 and 4, the tower water supply and return, streams 5 and 6, and the 75-pound steam and condensate lines, streams 7 and 8. We don't need to size streams 9 and 10 because those are streams that are a side effect of putting in the stream controllers, unit ops 3 and 4. There are several ways we can approach sizing process lines. One of them is to use the optimum pipe size relationships you see here. These are from the Peters and Timmerhouse book on process design. There's a separate relationship for turbulent flow versus laminar flow. You should notice that these are dimensional equations. They give the pipe diameter in inches based on the volumetric flow rate in cubic feet per second, the density in pounds per cubic feet, and the viscosity in centipoise. The numbers you calculate from these are not standard pipe sizes, so you need to take these as a guide to select the final pipe size. Another approach that works for liquid streams is to assume a pressure drop of 2 psi per 100 feet of piping. A third approach is to use a typical economic velocity. For water or similar fluids like benzene, that's going to be in the order of 3 to 10 feet per second. For steam, it's going to be on the order of 100 feet per second. So what we're going to do next is go into the flow sheet, change the units into something that conforms better to our problem, define a customized property set, and activate that. We'll define a stream group. We'll change our reporting options so that we can send reports to Excel. We'll size the lines in Excel so that you can see how the sizing equations work. We'll change the reporting inside CHEMCAD back to use CHEMCAD's internal reporting to avoid side effects in our normal use of CHEMCAD. Then we'll size a single process line so you can see how that works within CHEMCAD. Finally, we'll reset the flowsheet units to where we started. Right now, I've just entered into CHEMCAD. I'm connected through a VPN connection. I've got a valid license. I haven't opened my flowsheet yet. What I'm going to do first is set the default font in CHEMCAD to an Arial font. The reason to do this is so that I get a flow sheet that looks more like a typical process flow diagram that you would encounter in industry. Seeing them in Times Roman is fairly unusual. Now that I've done that, I can open my Explorer. I've already had this file open before, so I can just double click to open it. I don't need to save my changes. And CHEMCAD now has my line sizing example. Now, you remember that when I was working on this before, if you've already looked at the heat transfer videos, I'm in common SI units. These don't work well for the equations that I need to use. So to avoid possible mistakes in unit conversion, I'm going to switch these to American engineering units. Now you can see that my densities are in pounds per cubic feet. My flow rates are cubic feet per hour. I need cubic feet per second, but you can see that I don't get a cubic feet per second option here. My flow rate's in pounds per hour, and my viscosity is in centipoise. So this works well for the calculations I want to do. If I look at the properties for any one of these streams by doing a stream report, if I click on, for example, the stream property report, I get a lot of what I need, but not everything that I need. And there's just a lot of extraneous data here. So what I'm going to do is define a simplified set of physical properties that I can use here. To do that, I'm actually going to go into Stream Report, Customize Property Sets, and I'm going to say that I want to add a property set. And we'll call this line sizing data. Now in this set, I would like to have the mass flow rate. I'd like to have the temperature and pressure. I'd like to know the mole fraction that's vapor in the line total. For the vapor flows, I'd like to know the viscosity, the density, and the actual volumetric flow rate. And similarly for the liquid, I'd like the viscosity and the actual density and volumetric flow rate. So set this as active, say OK. Now if I want to look at one of these lines, at my stream report, I now have my line sizing data report, and you can see I've got a much more focused way of looking at what's happening in that stream. I can add a stream box, and what I'm going to do is select the streams I want. Streams 1 and 2, and 5 and 6, 3, 4, 7, 8. And it asks me what data set I want to use. So I will select my stream data set, line sizing data set. And if you zoom in, you can see that now I have just the data I want. The problem with this data set is that if I try to put it into Excel, it's actually goes in as a graphic rather than as a table. So let me get rid of this, and instead what we're going to do is tell CHEMCAD through the Options, Preferences menu to change our default report viewer. So right now it defaults to doing CHEMCAD's internal viewer, which gives us the tables or pages you saw before. I'm going to switch that to say that my report viewer is Excel. Now when I do this, I can go into my report menu, to my stream reports, and before I do anything else, I want to add a stream group. Okay, and that stream group, we'll call it lines to size. And again, 1 and 2, and 5 and 6, 3 and 4, and 7 and 8. The reason I'm choosing 1, 2, 5, 6, 3, 4, 7, 8 is so that all the streams relevant to E100 are together, all the streams relevant to E120 are together. I can say OK, go back to report, stream reports, and now you'll see that I have the option of using the lines to size stream group. So if I click on that, now you can see that it's because I set my default stream viewer to Excel, and I've set my default data set to the line sizing information, I get this nice Excel report. The stream reports typically separate data for the vapor portion of the stream from the liquid portion of the stream. In this case, I'm using the same sizing equation regardless, so let me clear the blank spaces out of here and move the steam data into the same lines here. I'll get rid of these potentially confusing headings and go ahead and give myself a blank line here just to separate these data from the rest of them. Remember that the sizing equation for the lines required the volumetric flow rate in cubic feet per second. So I'm going to calculate that. Now that I have the volumetric flow rate, I'm going to calculate the pipe diameter in inches. I'll use the turbulent flow equation, which is 3.9 times the volumetric flow rate in cubic feet per second to the 0.45 power times the mass density in pounds per cubic feet to the 0.13 power. And I come up with an optimum diameter of about 2.5 inches. Because I estimated the diameter using a turbulent flow equation, I should check the Reynolds number. I can calculate that as 4 times the mass flow rate in pounds per hour divided by pi, divided by the viscosity in pounds per hour foot, divided by the diameter in feet. and I get a Reynolds number of about 191,000, which is very definitely turbulent flow. I can now just copy this across the entire set of lines, and in all cases, I am fine assuming turbulent flow. This is a quick way to estimate all those line sizes, doing the calculations on your own. CHEMCAD can also calculate line sizes for you. If I pick let's pick the benzene feed. If I right-click it, a line sizing option, it will let me pick typical sizing for a liquid phase. Be sure to pick the pipe schedule. Schedule 40 is our default. And going through there, this is the reason I said earlier that we need to reset the reporting. So let me go back to CHEMCAD, fix the reporting preferences to go back to using the internal viewer. Let's recalculate this line size. Using typical sizing for Schedule 40, you can see it comes out to 2-inch Schedule 40. If I do the same calculation, assuming a 2 psi per 100 feet of line heuristic, I come up with about 2 inches. Another approach is to use a typical liquid velocity in the line. For something like benzene, it's going to be between 3 and 10 feet per second, so let's call it 6. And I come up with the 2-inch Schedule 40 pipe. So these all tell me about the same thing. It is possible to select more than one line and to do the line sizing calculation. However, CHEMCAD seems to remember the pipe schedule only for the first one you pick. So unfortunately, if you use CHEMCAD, you will need to do each line individually. Final housekeeping thing is to put this CHEMCAD back into the original engineering units we were using, so that if you do other process calculations, the numbers will still make sense to you. So what we've done is defined and edited customized property sets. We've defined and edited a stream set. We've shown you how to change the reporting option for CHEMCAD so that it will export data to Excel. And we've demonstrated CHEMCAD's line sizing capability. Hope this helps you out in your projects.